Hello guys, welcome back to Maison African Motives, still on Mathematics N5 on the question paper, which was written in February 2022. Yeah, now working on question number 3, where we are now focusing on the applications of derivatives, which is differential calculus. Remember, in your differential calculus, you now know the derivatives, but they can be applications like this question that we are having here. So I'm going to quickly rush through the questions that we are given. On 3.1, we are given f of x, which is equivalent to x cubed minus x squared plus x minus 10. Determine the coordinates of the point of inflection of f of x, and that's just 2 marks. Okay, so whenever you're dealing with the point of inflection, what you are supposed to know, guys, is that these are the applications of the derivatives. Okay, let me just try to reduce this a little bit. Okay, so like I was saying, these are the applications of derivatives, whereby at the point of inflection, the second derivative with respect to x, it should be equal to 0. So as we have got our f of x here, all right, so what we are going to do is to find the second derivative equated to 0. So that's it, x cubed minus x squared plus x minus 10. This is our f of x. So let's start with the first derivative, since we need the second derivative. So the first derivative with respect to x, we're going to drop exponent 3, which is going to be 3x squared minus 2x plus 1. So this is what you're going to have. Remember, minus 10 is a constant, so that's going to be a 0. So move on, since we need the second derivative. So we are going to find the second derivative with respect to x. Drop this exponent 2 by 3, that is 6x minus 2. 1 is a constant, so that's a 0. So this is our second derivative, which we said it must be equal to 0. So by equating this to 0, 6x minus 2 is equal to 0. We can be able to find the value of x, which is 6x is going to be transpose negative 2 to the right-hand side. That is going to be a positive 2, then divide by 6, both sides. So that means x is going to be 2 over 6, which is actually 1 over 3. That's 1 over 3. Okay, so we have the value of x, but the question was not for us to find the x coordinate, but it is to find the coordinate of the point, which means we have to find the value of y. That's a point, remember, x, y, that's a point here. So for us to find the value of y, we're just going to substitute into f of x, the original function, that is the value of y, which is going to be a third to the exponent of 3 minus a third to the exponent of 2 plus a third minus 10. We're just substituting in place of x. And by doing this, we are going to find our y as negative 263 over 27, if I'm not mistaken there. So just try and substitute properly. So therefore, the point of inflection is going to be given as x, which is a third, and y, which is negative 263 over 27, like that. All right, so that's our point of inflection from there. So these are actually typical questions that you can have or that you can be given. Take note how to answer them from the point of view that we have there. All right, the 3.12 is draw up the table of x for f of x, where x ranging from x is equal to minus 2 to x is equal to 3. Okay, so there you are required to draw a table for the function of f of x here, given the values of x from negative 2 up to positive 3. So that's the table, guys. We're just substituting these values. So here we're not going to waste much time. This is a direct question. So this is 3.12. Remember, your f of x was equivalent to x cubed minus x squared plus x minus 10. And we are given that we are supposed to have a table drawn from negative 10. So this is just a table. Let me see if I'm going to win here. All right, so that's it. I think we can just win here. Let me just put something of this nature. So we just need the values of x versus the values of y. That's it. All right, so that's our table here. We're gonna have our X values, then the corresponding Y values. So X is ranging from -2 up to 3. So you're going to have -2, -1, 0, 1, 2, up to 3. All right, so these are the values of X. So what it simply means, you are going to substitute. That is what the question is simply saying. You're going to substitute when X is -2 in place of X. That means f of -2, you're substituting -2 to the exponent of 3, minus in place of x, that's -2 to the exponent of 2, plus x, which is plus -2 minus 10. So that is what you're simply doing on your calculator, guys. Okay, so I'm not going to waste much time. Here we're going to obtain -24. The other one, you're going to obtain -13, -10. When 1, we are going to obtain -9, -4, and 11. All right, so these are the values that you're going to have by substituting the values of x that we are given. So as you can see, guys, it's simply a direct question that we have, whereby you're just substituting the given values. So without wasting much time, let's see what we have. On 3.13, it is now to draw a neat graph of f of x between these values, showing the turning points on it. So there we are asked to show the turning points on it. All right, so actually, we know that the turning point is taken from this part here that we had on the first derivative of f of x. That is where our turning point is located. The first derivative should be equal to 0. So what you're supposed to do is to indicate the turning point, but now just look at the marks. We've got 2 marks for that, so this is not fair. Okay, anyways, let us find the turning points. First, from our first derivative, remember our first derivative, okay, was 3x squared minus 2x. I'm going to work it this side so that it's not going to affect us. Okay, so let's just work our turning points here. So the TPs are taken from the first derivative, which should be equal to 0. So already the first derivative, we got it as 3x squared negative 2x plus 1. So we're just going to equate these to 0. So you can solve the equation either by quadratic formula or by factorization. That's 3x squared if you multiply the first term and the last term. So do we have any factors here? Let's try and see. We've got 3x squared. The factors of 3x squared, but when we add them, they must give us a -2. Do we have such factors? We do not have actually, because we must get a -2, but if we multiply, it must be a positive. So the only number that we have is -3 and -1, 3 and 1, of which on this, there's nothing that we can add and get a 2. So there we are supposed to actually use the quadratic formula. This question does not even make sense to me with marks. I think this part was actually to show this point of inflection that we calculated before. That was what is supposed to happen, the point of inflection, not the turning points. These guys, they're actually crazy. All right, anyways, let's see. From this part, because already the point of inflection is there, is a third, and this value here. Okay, so let's see what our graph is going to be, because there it's gonna take us a lot of time trying to figure out things which do not work at all. All right, so I'm going to present it here. This is 3.13. Okay, so we're going to have our f of x just from -2 to 3. Okay, so okay, let's just do this. Let's do this, guys. Let's do this. I'm trying to put something here. Maybe it will work. Don't know if it is going to be neater than I think. But I think we are going to win. All right. So definitely, yes, we are going to win. Then let's change this like this. Right. It like this. All right, just like that. Okay, so that's your x-axis and that's your y-axis here. So we've got a 0 here, -1, -2, 1, 2, 3. All right, so just looking at the values here, we've got more of negative values there. So you can just say this is -5, this is -10, this is -15, this is -20, this is -25. Okay, then the positive, we've got 5, we've got 10, we've got 20, just like that. Okay, so just name any points of your choice there. So -2 versus -24, maybe that's somewhere here. -1 and -13, maybe that's somewhere here. 0 and -10, that's somewhere here. 1 and -9, maybe that's somewhere here. 3, 2 and -4, that's 2 and -4, maybe somewhere here. And 3 versus 11, maybe somewhere there. All right, so as by the look of things, it's just like this. This graph is going to be something of this nature. All right, so it's going to be something of this nature there. All right, so the point of inflection, therefore, is going to be, remember, it was a third. So a third is somewhere here. So you can just have our point of inflection here. It was a third and -263 over 27. All right, so that was your point of inflection there. Just indicate on your graph. So this is your F. All right, so that was it, not the turning points. It was actually a mistake, that one. Okay, so these guys, sometimes they do make mistakes, but okay, since it's 2 marks, they will just give you those marks. It's not a matter of fact, actually. The 3.14 is use the table and the graph to estimate the value of the best root between x is equal to 2. They needed to say x is equal to 2 to 3, okay, of the equation, that is the one that we had, and then use Taylor's or Newton's method twice. Take note here, we are supposed to apply the method twice to determine a better approximation of this root. The root should be correct to 3 decimal figures, which is 3 decimal places. Okay, remember your Newton's rule, so you're taking from 2 to 3. Okay, so for the meantime, I just want to remove some of this part that I have written here, all of it. Okay, so take note, your answer is supposed to be taken to 3 decimal places. Okay, let's start first by the Newton's rule. What does it actually state? For us to have the value of x that we are going to have, we are going to use the formula of xn minus f of x. So we shall have f of xn, the one that you are given, over the first derivative of f of x with the n. So that is what we are going to actually have in this case. So xn is actually the first root that you're going to have, which is your estimate value. So from 2 to 3, you can just estimate your xn as, or your xn, which is your x1 in this case. You can just add 2 plus 3 divided by 2, the middle point, which is something like 2,5, because it's 5 over 2. 5 over 2 is 2,5. So that means you can start with 2,5 as your x naught, or your x1 or your x naught. I don't know which way or is best for you, but this is your first value. All right, which is 2,5. So here, as you can see on our formula, there is a need for us to find, okay, to find the first derivative, because f of x is actually there. Our f of x does not change. It's still x to the exponent of 3 minus x squared plus x minus 10. Okay, so we need to find the first derivative of x. So the first derivative is going to be, we did this before, we got 3x squared minus 2x plus 1. Okay, so now our x naught in this case, the first one, the first value is 2,5. So that means we have to substitute 2,5 in f of x, then we substitute 2,5 in the first derivative. That is what it means, guys. Okay, so let's do this on our calculator. We are going to say here f of 2,5. Okay, that's f of 2,5. What is the answer there? So actually, as for me, I prefer using a table than this way. Okay, anyways, let's substitute 2,5 here. 2,5 to the exponent of 3 minus 2,5 to the exponent of 2 plus 2,5 minus 10. Then you just round off to 2 decimal places. So this is 1,875. Okay, so you're obtaining 1,875. We do the same here on the first derivative, substituting 2,5. Okay, you're going to obtain something like 14.75. So I'm not going to waste much time here. All right, this is what you're going to have at the end, something of this nature. Okay. Now we have substituted f of 2,5 in the first derivative, in f of x, and also in the first derivative. Now that means here we are going to find another x from what you're going to obtain. Okay, we are going to have the x, another x, so that we can apply this method again. That is the Taylor's method again. Okay, so x naught being 2,5, so you're going to have 2,5 minus f of x naught, which you got here, which is 1,875 over 14,75. So this is what you're going to have, all right, which is something like 2,5 minus a fraction 1,875 over 14,75. So this is 14,75. So you're going to obtain something like 2,3, something like that, 2,373, because remember to 3 decimal places, so it's going to be 73. So it's going to be 2,373. Okay, so here we are now having the first solution. We have applied our Taylor's method for the first time. We have to apply again for the second time, but using the same formula. So which means we are going to find the first derivative again from this part that we had. Sorry, we are going to substitute, not to find, was already the first derivative are there. We are going to substitute again in this case. All right, so let me do this. So we're going to find f of 2,373. All right, so that means in place of f of x here, we are going to substitute x as 2,373. Okay, so if you do that, guys, you're going to obtain something like 0,105 to 3 decimal places. Then you go on again on the second derivative, you substitute 2,373 in the first derivative. You're going to obtain something like 13,147 to 3 decimal places. So that means we can have our second solution now. Xn now is this value that we have, the second one, which is 2,373 minus f of xn, which is 0, so you're now having 0,105 over the first derivative, which is now 13,147. All right, so we can do this from our calculator. Yeah, that is, we are going to obtain something like 2,365. All right, so that is what you're going to have now as the final solution. So this is the second part. So we applied for the first time, then here for the second time. So as for me, I actually prefer using a table like this. Let me just show you this table where I've got my xn, I've got my f of xn here, I've got the first derivative of xn, then I have got my xn minus f of xn over f prime xn. So actually in another class, or I'm going to show you how easily we can apply this table, because you just have to substitute your values and straightforward, you're getting your answers. But for the meantime, I think what we had is clear. All you need is to work on match questions. Guys, do as much questions as possible. Yeah, I think that one can actually help. All right, so that's what we had. And for 3.2, we are given that for a certain rectangle, the length of the longer side is 3 times the length of the shorter side. Okay. This we are given in terms of the shorter side. If you are to cross-check, everything is given in terms of the shorter side. So let's start by just having our presentation of what this question is actually saying. So this is 3.2. So we're given that there is a rectangle that we have here, whereby its length is 3 times the shorter side. And we know that the shorter side is the width, whereby we can just say, okay, let the shorter side be equal to x. Let x be equal to the shorter side. So if x is representing the shorter side, therefore L is equal to 3x, because it's 3 times the shorter side, which is 3 times x. So we've got 3x here and we've got x here, if we are to write in terms of x. All right. Now let's move on and see what the statement is saying. Now we are given that at 3.21 here, at what rate is the longer side decreasing? Which means it must be a negative if it is decreasing. So they are asking us, at what rate is it decreasing if the shorter side is decreasing at a rate of 2 meters per minute? 2 meters per minute. That is where this is decreasing. All right, we are given the rate at which the shorter side, of which our shorter side is represented in terms of x here. We said the shorter side here, let it be x. So if it is x, that means the rate of decrease of x with respect to time, because a rate is with respect to time, is 2, but it's a decrease, so it's going to be -2. So it's -2 meters per minute. All right. Now the question is asking us at what rate, okay, let's get back to the question. At what rate is the longer side? Okay, here we actually have our length is equal to 3x. Let's say this is our length and we can just write it as y is equal to 3x. So if we can have a presentation like that, we need to know the derivative of that y with respect to x. All right. This is what you're going to have. The derivative of y with respect to x is just going to be 3. This is a constant. We've got 3 times x, so we're going to have our 3. But remember how to connect this part here when you're dealing with the rates of change. We have this, if you use this to volume, there is something like whereby you can have maybe dv dt, whereby you can actually multiply by a certain derivative of v with respect to h, then you multiply that h with respect to t. All you need is for you to have dv dt at the end, whereby these two must cancel, the h and the h are the same. So for us to have dx dt, which is the rate of change of the length now with respect to the shorter side, that means we can substitute, we can have this formula as dy dx is equivalent to, remember, we are referring to time. So it is going to be dy dt, which is the change of length, because our length now is represented by y. So this is the change of length with respect to time, times, now we need to have dy dx, so it is going to be dt dx like this, so that this can cancel. Take note, these two must be the same, dt dt, so that they can cancel, it remain with. But you are calculating this is the one that you need, the rate of change of length with respect to time, because that is what the question is saying, at what rate is the longer side, which is the length. Okay, so from this part that we have, we are going to write this in this manner. We have the values, we can substitute them. Okay, let's substitute and see what you're going to have. We are given previously that dy dx we calculated as 3. So we got 3 is equal to the rate of change of the length with respect to time, which is the one that we need. We do not know this, times dt dx, here we have got dx dt, which is minus 2 meters. What about dt dx? dt dx is simply the inverse of this, so it is going to be 1 over negative 2. That is the inverse. So we've got 1 over negative 2. So what can we do to calculate dy dt? We can just divide by negative half both sides, because this is cancelling, so that we can cancel this. Divide by negative half both sides. Actually, this can cancel. This can cancel. So we're left with 3 divided by negative half, which is giving us dy dt, which is the rate of change of length with respect to time. So 3 divided by negative half is something like negative 6. Just 3 divided by negative 0.5. That's a half, which is negative 6. So we're going to obtain negative 6. And this is length, which is in meters per minute. So it is changing at negative 6 meters per each minute. That is what the question was all about. So guys, understand the presentation and the terminology that you are given when answering these typical questions. They are not much. All you need is to understand the terminology there. All right, anyways, on 3.22, at what rate is the enclosed area decreasing when the shorter side is 6 meters long and decreasing at a rate of 2 meters per minute? So it is still decreasing at 2 meters per minute, but it is equal to 6 meters. All right. Guys, now you are dealing with area. All right. Now we are dealing with area. So I want us to get back to what we had before, because we need to know the rate of change of area. Okay, so we are going back here where we had the length and the width here, 3x and x. So we're given that the shorter side is 6 meters. That is the shorter side. So which means if this shorter side is 6, then this is going to be 3 times 6, which is 18. So for area, we can just multiply to know the exact area, which is length times width. Remember that's a rectangle here. So it's going to be length times width, which is 18 times 6, which is something like 108 square meters. That is the actual area. But what about the area in terms of x? Our area in terms of x is going to be given by length times width, which is 3x by x. And this is going to be 3x squared. So this is the expression for the area. All right. So as we are asked to calculate at what rate is this area decreasing, all right, so this is 3.22. If we are to refer to area, therefore it must be dA, that is the change of area with the change in time. That is where the area is actually decreasing. So as we had this part, let us connect what we had. Remember what I said in terms of the volume and that we had here. This consideration that we had, the volume and time. So it must be the same thing. If we are to check here, we have got our area. I want you to see what is happening here. We have got our area here in terms of x. So which means here we can actually have dA dx. We can have dA dx from this. Here we have got already dx dt, because we calculated this dx dt already here. We have got our dx dt already that we calculated before. So that means we can connect these two to calculate dt. How can we connect this? Okay, let's get back to our formula. If we can write this as dA dt is equivalent to dA dx times, it must start with dx since this is dx, so it must be dx dt. So by doing this, we have connected area and the shorter side. So dA dt, which is the rate of change of area with respect to time, is equivalent to dA dx. That means we have to find the derivative of A here with respect to x. dA dx from this, what are we going to have? Because area is there in terms of x. This is going to give us 6x. Okay, 2 times 3 is 6, and to subtract 1. So that means we have got our dA dx here, which is 6x, times dx dt. Okay, where do we have dx dt? We have this before our dx dt. It was given as -2 meters per minute. So we're just going to substitute -2 meters per minute. All right, so this is going to be -2 meters per minute. X, because this is supposed to be a numerical value. So where are we going to have this X? X is now going to be taken from here because we are given that the width, which is the shorter side, that is our length, is 6 meters. So we are going to substitute 6 meters from there. All right, so that means our dA dt is going to be 6 times 6 times -2 meters per minute. All right, so take note, the 6 that we have here is actually in meters. So the moment that you're going to multiply meter and meter, it is going to be square meters, okay? So 6 by 6, that's 36 times -2, which is -72 square meters per minute. So that is the rate of change of which area is decreasing at -72 square meters per minute. Take note, this is area. If it was volume, it was going to be cubic meters per minute, like that. All right, so I hope we had something from this question. I understand that we actually need to work on more questions that can actually help if we are to revise as much questions as possible. So what we are going to do as time is going on, I'm going to come out with many questions so that we can at least understand how do they ask these questions and what are we supposed to do when answering these typical questions. But as you can see, it's a total of 17 marks, which is a lot in exam that you're supposed to obtain. So guys, keep on in touch with Maison African Motives, and don't forget to share our videos and platforms to your friends also, so that they can benefit from this platform, and revise as much as you can, preparing yourselves for the exams which are ahead of time. So that's it, guys, till we meet again.